we have the principles of OOP. Okay. So what are the four important concepts of OOP? First one, we have encapsulation from the root word capsule. No? Um, you put things inside a capsule, encapsulate. So it's the act of appropriately grouping related states in a classes. For example, a while ago we have house number inside the address. No? It wouldn't make sense for that field to be inside the address book. No? I mean, why would it be? So that's another important concept in OOP. You should learn how to group related states together, okay, in one class. Then next is we keep states private. We haven't really talked about access modifiers, but I will clarify this on the next slide. So changes in the internal states are done within the class itself through public method calls. Okay. Users shouldn't have access to your private states because they might make erroneous changes. Okay. So we'll clarify. Okay. For example, we have a person class. Okay. So we have a name and then an age. Okay. A new person. So person is a person. No? Okay. So we print out the age person.age since just like in C, we access the properties through just the dot syntax. Okay. So it's okay. It prints the number 8. And then finally we have person.age equals -5, which obviously is wrong because an age cannot be negative. Okay, so that's what I mean by erroneous modifications. Okay, um, this might seem obvious or stupid for some of you that we assign -5 to an age, but this is just a simple example. What if there are more complex objects, okay, and we don't understand and we don't know what an erroneous input would be, okay? So this is just a simple example. Okay? So we add a private modifier to the age in person. Okay, we add the keyword private. What happens then? This will happen to to your editor, which in my case is IntelliJ. Okay, it's red because in the eyes of the compiler, there's no such variable as age because it's private. It's hidden from the main program. From outside the class, it's hidden. So they don't really see what age is. So what do we do? In our class, we add getters and setters. Okay, these are what we call it in OOP, getters and setters. Because it's declared private, there's no way for the main program to have access to age. So how do we give access to it? We make these methods, getters and setters. So get age returns the age. Okay, basically that. So you might ask, what is this for? I'll repeat. No, it's to prevent other people from making changes to your um your classes. Invalid changes. You're preventing invalid data to enter your classes. Okay. Kasi, di ba, especially in the tech world, no, almost all code is open source. Okay? So, you might download other people's classes, because we don't have to implement it ourselves. Okay? So, when we use them, it's not like we know how they implemented it and we start changing yung mga properties nila, which is wrong. Okay. So to prevent other users from making mistakes using your API or your classes, we limit them with the getters and setters. So we make a setter called setAge, which receives an age, an integer. Then we check if if age is first non-negative before we set it inside. Okay. So with this, we are able to control what the age variable contains, okay, which is non-negative. It's always valid. Okay. So if it's not, we just throw an error. Okay. Don't worry about this first. Just know that we're signaling an error. Okay. So let's try to run the program. So from here, okay, we change the program to become this one. Okay. So as you can see, system.out, which is just a print statement, person.getAge, no longer person.age because it's not accessible. Okay. So how do we get the age? We use the getter that is defined in the class. And then when we set it, we use person.setAge, pass -5, and an error is received, invalid age. Okay. So we are now able to control what goes inside and make sure that data is valid because we set the age variable to private. Unlike here, a person is able to freely set what values go in, okay, which is very insecure. Sige. Okay, so next concept is abstraction. So it's a bit of an extension of encapsulation. Okay? So your aim here is to hide implementation details. Okay? And make it easy to use by exposing high-level mechanisms only. For example, in this age, no, a person who will use your class person, okay, knows that set age will set the age. Okay, diba? It's clear, doesn't make sense. I don't care if you have checks inside or what. As long as I know, as long as it's clear to me that set age will set the age of the person. Okay. So, I mean, this might seem too simple. So let's say here, okay, we have the main class here, okay, the driver class in the previous example, and then we have address book. Okay. I know, for example, you know that I'm the one who made these, right? But if you were to use this class, okay, for your project or whatever, you know that the address book can store an address. Okay. You don't care if I will do checks, duplicate checks inside or whatever, as long as you know that that the store method stores an address. Okay. You won't need to care if I used an array list, a collection, or whatever. Okay. As long as it's clear to you that the book stores. No? I mean, I can change the implementation inside and you won't care because the store method stores. So that's the importance of abstraction. It makes programming much easier and more intuitive when it comes to the main program. No? I mean, even maybe a Prog 1 student can understand what's going on here, right? Because it's clear, very clear. Okay? So it doesn't matter. We're hiding the implementation behind. Okay? What the user sees are just these methods, these simple methods, which are clear what happens, what the consequence is of using them. Okay. So if it's still not clear to you, another way of abstraction, another good example of abstraction is turning on your PC. Okay. What do you do to turn on your PC? You press the power button, right? And it turns on the PC. But you don't even have to think about the circuits or the electricity, the flow of electricity, whatever. You don't need to know about that. It's abstracted from you. Okay? With good engineering, all you have to know is that when you press this button, it opens the PC. So similar concept, no? All you know, if you use .store, it stores the address. Don't care about what happens within. If you check for duplication or other errors or no. Okay, so that's the concept of abstraction. Okay. Next is inheritance. Okay. So objects classes can inherit from superclass. Okay, so common logic can be passed down, both states, the fields, and the methods. Okay, the behavior. So child classes can add new behavior and states of their own if they want. So let's go to an example. Okay. So we have a class person. Okay. It has a name and an age. Okay, private. You already know what that means. Okay. And then we have a method introduce, which called prints, hi, I am name and I am age years old. Then we have a teacher, which extends from person. Okay, so this is a child class. Okay, it extends from person. So we only have a string school here, then a constructor. Okay, so super pertains to the super class. Okay, so when we're calling super name age, we're actually calling person name age. Okay, we're passing name age. Then this school that equals school. Then we have an introduce here. Okay, so we have an introduce in person, but we also have an introduce in teacher. Okay, so next is we also have a student which extends from person. Okay, so same concept here and same concept, except this one calls super.introduce, which means it will execute this. Okay, this is super again pertains to person. So super.introduce will call this, and then will print I also study at school. So it will print this first and then print this. Note that since age is private in person and name is also private, we have to make a getter pala. Okay? So that's why we call this dot get name, so we can get the name. Because it's declared private, so even child classes can't have access to it. Okay, so that's why we have to make a getter. So name, the method is visible because it extends from person. Again, we defined that logic is passed down, both states and method. Okay, it just turns out that name is not visible because we declared it as private here. But if it were protected or public even, we can directly put name here. Yan, sige. So that's inheritance, no? And here's the main program. So we have a person object, we have a student object, and we have a teacher object. So we did person.introduce, student.introduce, teacher.introduce, and notice that even if they extend from person, when we called introduce on the student, this is the one executed, okay? Not the person's implementation. So we can override the superclass's implementation of a method. Okay. So here it also overrides the implementation here. So that's the concept of inheritance. But note that these two also have name and age. It's just that it's inside the private class. Okay. Okay, so next, polymorphism. Okay, this is extended from the concept of inheritance because we can't have polymorphism if there's no inheritance. Okay, so polymorphism also translated as many shapes. Okay, so even if an object of a child class is upcasted to a parent type, the implementation of the child class is still used. Okay, might be a bit of a complicated explanation, so why not show it in an example? Okay, so we have two persons here. So person type, okay, but notice, so we this is normal, we created the person, but notice in the second line we store a student inside a person type. Okay, I mean, it makes sense, no? A student is still a person, so we can put it inside. Okay, so a student is upcasted to a person. Okay, so here we have a student, so new student, teacher, and a teacher type. Okay, this is the other ones are more normal. Okay, then we created a person array. Okay, remember it's a person type. Okay? And then we store inside the array, we store person A, person B, student, teach. Okay? And then we did a for loop, and then we just made a print. We just did introduce. Okay. So notice person A introduced himself. So, hi, I'm a person and I'm 8 years old, which is somehow correct. Okay. And then person B did introduce. Again, person B is what data type? Person, right? So shouldn't it print hi, I am blah blah years old only without printing I also study at UP? no? Since it's a person data type. But no, okay? This is the concept of polymorphism. We stored a student inside, a student type. It's still a person, right? So that's why it didn't cause an error. Okay, so we upcasted it. Okay, and then when we called introduce, it called the implementation of student. Okay, not person, because it's the student inside, right? Okay, so how about for the others? These are easier to comprehend. No? So this is a person array, and then we placed a student data type inside, a teacher, okay, inside. So respectively, they were called. Okay, so here at the third element, it printed as a student. Okay, the fourth element, it printed as a teacher. Okay? Makes sense. Okay, so that's the power of polymorphism. You can the data type is much looser, I'd say, because you can put the subclasses inside superclasses data types. Okay, so the implementation of the children class is still called. Okay, it's not overridden. Okay, so that's all. Okay, let's go to the conclusion. So the main points discussed today are OOP treats problems as objects interacting with each other. Okay? Classes, parts of a classes. Okay? They have fields, methods, and constructors. Fields are the states, the data. Methods defines the behavior, what class can do, and constructors define how classes are made, how objects are made. Sorry. Okay. So classes serve as blueprints, while objects are instances of a class. Okay. So classes are groups not pertaining to any specific entity. Meanwhile, objects are a specific entity of a class. Okay. So the four principles of OOP are encapsulation, grouping data together, no? Declaring them private, making changes only within the state. Okay. Next is abstraction. So hiding the implementation details, making it easier for the users. Okay. They don't have to worry about what's happening in the backstage. Next is inheritance. So inheriting states and behaviors from superclasses and then overriding your own. Okay, why not? The next is polymorphism, calling the same method in an array of a class doesn't necessarily output the same. Okay, because if a child class is stored inside, the implementation of the child class is called. Okay, so that's all. Thank you for listening to this lecture. If there are any questions, please email me at my organization email or just text me on my son number. Okay. Thank you.